Hey everyone, it's Bradley Bush with another algebra video for you. Today we're talking about finding the greatest common factor. Thanks for coming to my channel. I hope you enjoy it. If you do, please subscribe, give me a thumbs up, and leave a comment. First, let's talk about distribution. Do you guys remember distribution? It's that fun thing you did a long time ago where, say, there was an A out front here and you had parentheses, and inside the parentheses you had B plus C, and you're supposed to distribute the A through. So you pushed it through to the B, and then you pushed it through to the C, and then all of a sudden the first term, which was the B, had an A multiplied by it, and the second term, which was the C inside the parentheses, had an A multiplied by it. So you had AB plus AC after the distribution. Well, factoring is just the reversal of that process. So you start out, with the A everywhere, right? With the A times the B and the A times the C. And you notice, hey, wait a second. Every one of these terms has an A. So it kind of looks like this. It kind of looks like the ending of a distribution process. So I could probably reverse that distribution process and go backwards and pull that A out to the front. So that's what we do. We've got an A with the B, we've got an A with the C, and we just pull both of them back out. And there we go. We have the A sitting out front, and then we have in parentheses B plus C. That's all factoring is. It's just the reversal of the distribution process. So when we talk about pulling out a greatest common factor, really what we want is we want to pull out the largest number and or variable combination that is shared by each term in an expression. We abbreviate greatest common factor GCF because it's too darn long of an expression to always say every time. So the GCF, we're going to pull it out, and here's an example. 18x to the third power plus 27x squared. So I first look at the numbers. I've got 18 and I've got 27. Do they share anything? Any factors? Well, I can't make 18, so 18 times 2 is not 27. What are other factors of 18? How about 9 times 2? Well, what is 27? 27 is 9 times 3. Look at that. They share a 9. Okay, so the 9 is common, so we can pull that out. How about now the x's? Well, we've got 3 of them in the first term because we have 18x cubed plus 27x squared. So we've got 3 in the first term and 2 in the second term. So they both share at least 2. The first one just has 1 extra. So we can pull out x squared. So if you notice, if I pull out 9x squared, what happens? If I pull out a 9 and I pull out an x squared, what's left? Well, from the first term, we pulled out the 9. So the 9's gone, and so we have a 2 left over, and we pulled out 2 of the x's. That means we just have 1 left over, so we just have x. And what about 27x squared? Well, we pulled out all of the x's, both of them, and we pulled out the 9, so all we have left with is 3. So that's really all we have. When you pull out the greatest common factor, which is 9x squared, you're left with 2x plus 3 in parentheses. So our answer would be 9x squared times the quantity 2x plus 3. Here's another example. If you look at these two terms and we're supposed to factor out the greatest common factor, we have x squared times the quantity x plus 3 plus 5 times the quantity x plus 3. As we're looking at it, we notice they both have an x plus 3. So if we pull out the x plus 3, from each of them, we have x plus 3, and what do we have left? Well, we have this x squared, and we have this plus 5. So there we go. When you plot the common factor, you have quantity x plus 3 times quantity x squared plus 5. So let's do a few more examples. I think I have 5 examples here. Lucky you. Let's do the first one. 16x minus 24. That's example A, and we're supposed to factor out the GCF. If we look at 16 and 24, what do they have in common? Well, 16 is 8 times 2. 24 is 8 times 3. So they have an 8 in common. So let's pull out an 8. Do they have an x? Any variables in common? They don't. So if we are eliminating the 8 from both, then we have 2 and an x left over in the first term, and we just have a minus 3 left in the second term. And that's it. Done. How about B? 3x squared plus 6x. Well, what do they have in common? 3. 3 times 1 and 3 times 2. 3 times, so we have 3x squared plus 6x. 3 and 6 share 3, right? So 3 times 2 is 6 and 3 times 1 is 3. So we can plot a 3, and they both have an x. One has 2 of them, but they both at least have 1. So what's left over? Well, we took the 3 out when we factored, and we took one of the x's, so we're just left with x. The second term, we took the 3 out, and we took the x, so we're just left with 2. So when we're factoring out the greatest common factor, we get 3x, and what's left over is, in parentheses, and it's x plus 2. Awesome. Let's do the third one. These are moving right along, right? Let's see. We have 6x to the 4th minus 18x cubed plus 12x squared. The numbers 6, 18, and 12, those all share 6. So 6 is 6 times 1, 18 is 6 times 3, 12 is 6 times 2. Okay, so we know we can pull 6 out because all of those share a 6. And x is 1. The first one has 4, the second one has 3, and the third one has 2. So they at least all have 2. So we can plot 2 of them. What's left? What is left? We pull out the 6. The 6 is gone, and we took 2 of the 4 x's, so we just have 2 left. And the second spot, we took out the 6, and we took out 2 of the 3 x's, so we're left with 3x. And the second one, we took out all of the x's, and the 6, so we just left with 2. And that's it for that one. We're on the fourth one, which is D, example D. Let's see. 4x y squared plus 2x squared y minus 6xy. So it looks like the 4, the 2, and the 6, they all have 2 in common. That's nice. 2 times 2 is 4. 2 times 1 is 2. 2 times 3. So yeah, we can pull out a 2. And what else? We have x in the first term, x squared in the second term, and x in the so they at least all have an x. We can plot an x. How about y's? We have y squared and y, and then y. They at least all have a y. So let's plot a 2xy. And what's left over? Well, we took 2 from the 4, and we took an x, the only x that was there, and we took one of the y's. So we have 1 left. So we have 2y left over. Second term, we took the 2 and the y and one of the x's, so we're just left with x. Not very much, huh? Once we took out the 2xy. And the third one, we took the 2, we took the x, and we took the y. So we're just left with 3. Minus 3, actually. Positive 3. And we're done. So that one wasn't bad. And now we're to our last one. And as we look at this, it looks a little weird, right? But we notice something. The 2x minus 5 is a term that both of them share, and that's the only thing they both share, because we have x squared times quantity 2x minus 5 in the first term. The second term is negative 7 times quantity 2x minus 5. Or in other words, minus 7 times quantity 2x minus 5. So they both share a 2x minus 5. Kind of looks like the end game, right? Kind of looks like this, where they both have an a. That's that x, 2x minus 5. This kind of looks like the a, right? So if you pull that in front, then what do we have? We have 2x minus 5 out front, and what's left over? Well, we still have this x squared that needs to come down. And we have the negative 7 that comes down too. So that gives us 2x minus 5 quantity multiplied by quantity x squared minus 7. And we're done. That's it. Hopefully this was helpful. Have a great day.